Hello, welcome back, everyone. So let's start with the new people. New person on the call. Hey, Jeng, would you like to do a quick self intro and maybe the questions that we generally ask new people are how did you find out about this group and what do you expect to find here?
My roles in Google, we created IX and also doing work like a new production introduction. I've been working in GPU for almost 8 years, 7 years and a half. So basically, we're working on DIX. So basically, I joined this group because Kieran is leaving the group. So I'm trying to take over what he has been doing, and also from this group, I want to know more about OCP and how that different between the Google DIX and OCP, and how can we contribute to this group.
Okay, excellent. Welcome to our group. I can maybe throw in a quick answer to your last question. The OCP TV spec that we have been working on developing in this group is actually quite close to the Meltdown one that you might be already familiar with.
Mhm.
It's like the version 2 of that, and we've added a bunch of fields and agreed on how that is used. And we have some APIs already published for that. There's a Python one, there's a C++ one, which was maintained by Dylan Hawks, if I remember correctly, from Google. But he's in not in the calls anymore. I think Igor is looking after this right now, but he's out of office this week. So those are like production APIs. So you would use them in diags to output the spec without actually going into producing all of the JSON and formatting and all of that.
Mhm.
And yeah, there's a bunch of diags that we have in the open source for the group, and there's likely a bunch of diags that are still private and using the spec as it is. Basically, this spec is now a mechanism for interaction between executors and diags and a sharing mechanism between the different companies and so on, like hyperscalers, ODMs, and all of that. So that's like a very quick summary of what we're doing here.
Yeah, sounds good. Yeah, I'm still learning all the concept of OCP. Yeah, there's some similarity between the Google, like a lot of similarity between the currently what we're using, the Melton and also the OCP. Yeah.
Yeah. So there's a link in the chat right now that I posted. That is the meeting notes, that the document that we have. If you click on it, I can click on the share button so you can see it. And usually we add an agenda and meeting notes as the meeting is ongoing there. Um, you'll also find the links to the various projects, or maybe I should put them in a more obvious place. The main what I'm referring to are the repos that we have on GitHub. There's a main one with the spec, and there's other repos with diags and APIs and all of that.
Mm.
Okay, cool. So again, welcome. We hope to see you frequently if you're filling in for Kiran,
Yeah.
and let's continue with the other bits. So as usual, let's start with the status. I can start it. I have an update from Van that was working on the result viewer. Um, she is unable to join today, and we'll have more details maybe at a later date. But mainly the update is that the code base for the result viewer is on GitHub now, and it is usable as per the demo that we had a while ago. Let me put it in the chat here as well. Um, Other than that, Venkat, any updates you want to share for this week?
I think mainly CTAM now kind of merged into main. This release into main. I think Adrian, you and I been kind of discussing about like adding some test cases. I'll work with you and Rajat to have some unit testing so we can set up the CI. Yeah.
So for Jing's benefit, since he mentioned GPUs, maybe can you give like a short info about what this CTAM is?
Sounds good. Yeah. So CTAM is the repository of like compliance tests for GPUs, mainly around telemetry spec, the RAS spec, and like the firmware upgrade spec, which I think the OCP GPU work streams kind of worked on. So and these tests kind of act as compliance checks to make sure those implementations of the redfish schema and the general kind of uh, uh, information mandated by the spec is implemented correctly. So yeah, I think Rajat from Microsoft started that, and uh, the folks right now from yeah, bunch of hyperscalers and GPU vendors kind of actively using or in the process of adopting it. So
Okay, thanks,
Yeah.
Ankat. And thanks for the update as well. Vincent, do you have any updates?
Nothing. Let me try to see if there's been a little bit more engagement with vendors. But other than that, yeah, nothing terribly new to share this week. I did get to chat with Bijan, the CTO of OCP, who reassured me and said that they are looking at putting us on the center stage for the next OCP. He realizes we haven't had a chance to chat to present anything last year. So that's not really quite an update, but more a recognition that we could have the center stage this year if we have the right level of updates. But yeah, that's pretty much it, I think, at this point.
Yeah, thanks, Vincent. We should have actually some good updates by the time that comes in October. Like we have the Resolve Viewer, we have more DIACs, we have AutoVol, but I'm asking Vinit right now to come into the meeting to present that because it was actually on the agenda. So yeah, that should be interesting. Now we'll need to figure out who actually goes and does the talk, though. That's always a discussion.
Yeah.
Okay. Thanks, Vincent. All right, Juan. I left you last for the updates because you also have this demo thing. So if you wanna share any updates for this week, and then go into the demo for the results as well.
Oh, well, okay, thanks. My update is my demo. And I did go over this thing with Satish already last Friday. Yeah, so he suggested a couple more things on top of it, but I haven't implemented those. But here's this. I just want to show what I have. Can I start or?
Yeah, go ahead.
Okay. Let's see. This one. Okay, so basically we've been talking about this PCIe lane margining diag output format for quite a while. That's actually how I got involved in this group. So anyway, we had a bunch of discussions, and finally, I kind of made up my mind and actually put into what I wanted to be. So this is actually, I think the turning point was previously we kind of came about it from a diag developer according to the spec point of view, not really putting like ourselves as the consumer of the output. Like once I kind of get this, the 3-4 weeks ago, we have a demo of the OCP diag resolver. It's already open source. I was able to see the output from the end result, like what the user sees. And as a user, I kind of already know what I want to present. So basically, how it goes in my version of the lane margin test is that it will, you can pass it a file name. It can be just a file you dump these artifacts into, or it's, in my use case, it's a name pipe that created by another wrapper thing. Okay, so what it does is it calls my lane margin test as a sub-process binary, because the lane margin test that's open source already, it's a very generic one. It only covers the PCIe spec part of things. It has no idea of the DUT system. For example, okay, it only uses the PCIe BDF address. It doesn't know which P slot it's in. So it cannot give accurate repair instructions from the diag result. Therefore, it's called by another entity. So it creates a name pipe. So the LMT string these artifacts to that entity, and then the entity will convert these PCIe unique address into dot specific hardware info type of thing. And of course, internally we do another conversion to our like previous version of the OCP format, and present into the other reader like this one, or like the open test output. So basically, when I run it with this converter, I actually have 2 points I can extract this artifact. One is this one I'm showing right here, that's using the OCP diag resolver, showing just the output of the binary, the generic LMT. Any questions so far? No,
I don't have anything. No.
No. Okay. So yeah, basically the in this viewer, this is it has a test run, artifact, test step, and the logs, right? And it just parsed the JSON, and because I don't have any specific system information, the hardware component part is pretty empty. I only have the BDF address and the receiver point, which, like in this case, there's only 2 receiver ports. One's downstream and one's upstream port. There's no retimer in this case. Yeah, it's pretty empty, because I don't, the LMT, generic LMT doesn't have all this information to populate. It's the other converter that fills these in. And parameters, basically hide all the lane margining parameters. And yeah, it shows the date time and status, result, all these things. And in the test step, okay, so since there's 2 ports and 1 link, that's there are 2 steps. Each step is correlates with a port, a receiver port on a link. This way, because it correlates where the smallest kind of hardware component, you can pinpoint the failure and you can give repair instructions. Underneath the step, there are all the lanes. The lanes of all the links and lanes are running in parallel. So, but this is how I set the scope of a step. Yeah, so there'll be a bunch of steps running in parallel. So a step has this name, the BDF, and the receiver number. I guess that's this is a passing test, so there's not much things else to show. Then there's the final diagnosis, which it has 16 lanes and all passed. The hardware info, which is correlates to the DUT info, has very limited information here. Okay, so this is the meat of things. The way I present the measurements, there's only these few fields that I can populate information into, and I don't want to generate like overload all the too many artifacts. I want to just present what user, what I think user would like to see, putting myself as a user. Therefore, I kind of I put the lane numbers for each measurement in the name, so that I can use sorting to look at the per lane results. Okay, so after the lane number, I give it what kind of measurement it is, whether it's eye, height, width, or initially it reads the hardware parameter for the lane margining. I cram those into one measurement as JSON string embedded into a string, right? A measurement string value. And you can see in the unit, I kind of cramp a lot more information in addition to the unit. So here you can see there's the UI for the eye width, but I also put in what I specify the boundary is. Like here it's at the BR, this BR rate, that because otherwise it's necessary information to make sense of the measurement value. And okay, and I also output what how should I put it? Okay, what derives the ultimate diagnosis, right? Only the necessary information. In this case, I'm scanning the signal I. There are a lot of margin point that has no error. I eliminate those measurement output. Those are kind of just assumed, and because they really don't say much to the user. Okay, so there are also like some measurement require like eye height, eye width, but others kind of want to see the actual margin from the center. And then there's the actual measurement points at the boundary of the eye detection, where it actually sees some bit errors. So for example, okay, this is lane 0 step BR result. This is the measured error rate, and this is the unit at which step correlates to the offset. Like in this case, it's 15% UI, and direction is right to the center. Okay. In this use case, it's scanning the eye, so it's expected to have these BRs higher than the specified failure that exceeds the error limit, because that's how you detect the eye boundary. In this case, it's not gonna raise a failure because it knows it's doing eye scan. It's not putting in a validator. As you can see in this every measurement status, okay, it errors out at this offset. Basically means there's more error than the limit. But in the status validator, I'm allowing error out as a valid measurement. Yeah. So then it repeats for all the lengths. And that, okay, so
Can I ask a more basic question?
Yep.
So for the PCIe, because here you only put the receiver as the maybe the hardware for the to represent the PCIe link. In that case, how can we like how does the hardware ops people knows which component to replace if there is something wrong with the transmitter? Because you are only having the information about the receiver, and if the link is bad, it can be the cable is bad, or it can be the receiver is bad, or it can be the transmitter is bad. Like if the OCP standard only says like we're only representing the receiver side, like how can we let hardware people to replace the transceiver?
This is a very good question. Yes, you're absolutely right. Because receiver doesn't know if it's bad. It cannot tell. Only the listener can tell if someone's bullshitting, right? So the mindset for this diag is it's a system integration test. It's not a component test. So it's there, you just mentioned there's a lot of pieces putting into this integration, right? And it's testing that all the channels, like what's in there, like there could be a cable, right? Or the plugging adapters, things in. There's no way you can pinpoint which component to replace from this diag. It only validates if you have a good system integration, right? So the best it can do is to tell you if a receiver hears things clearly or not.
Okay.
So,
yeah, I can also add a couple of things. Yeah, I think that's what I mentioned. Yes, we cannot say whether the transmitter is transmitting bad signals. It's only the receiver where we can check the integrity of signal. And this gives us some opportunity to say like where to start the debug. Like it's not a like pinpointing the failure, but at least we have a starting point to start, like starting with the reseat of the receiver or a cable swap or a component swap and things like that. But yeah, this is just a starting point for the receiver.
Yeah, because in our case, it's more like in our dikes, we have some issue with how we can help the hardware people to understand like which component to replace. I don't know if OCP has a standard for the PCIe, like how we could represent the PCIe bus. Because previously we can target, like for example, a GPU is bad, then we can target the GPU. But PCIe is quite different. It can be the cable is bad, it can be the adapter is bad. Like in this case, does OCP has any standard way of representing a PCIe link?
That's what I was talking about in the beginning, that there's another entity here that converts these PCIe address to your duty system specific information. It can pinpoint which receiver it is, be that the endpoint or the root port or a retimer pseudo ports. So it can point where the receiver is. Okay, if you have a good modeling of your hardware system, you can have that information say what's talking to this receiver. And then you have these components in a link. From that, you can derive a triage prescription, like which, like whether it's cable or what you swap to repair, to try again. So that's the best I can think of.
Okay, yeah, I understand. Thanks.
Yeah. So one thing that Satish proposed is that this thing, the parameter, basically, this is per lane. You have a SerDes file. You can extract these the capability of how do you convert, for example, a step to an actual offset, right? That's coming from the parameters. And you, even though in the link, all the at the port, all the SerDes have the same parameters supposedly. Okay, I'm still reading every lane information, but I crammed it here as one measurement just for review purpose, but it doesn't validate if I actually read error information. So one thing Satish proposes to have a separate kind of step or something to measure each individual parameter to see if it's within the valid range.
Yeah, because we have seen some regressions with the new firmware where we might see some invalid combination of these parameters. So I agree, it's more of a bug, not a hardware degradation or hardware defect, but still it will be a good check to have if it's not too much of information.
Yeah. I think that's it.
I have one quick question. So yeah, I think last time we synced up. Is it the same JSON which you attached in the GitHub discussion? It's different.
I think so. I think this is the same one.
Okay.
Yes.
Because I'm basing off of my design with the JSON which you uploaded. So one thing as the team, like we are slightly deviating. I mean, we're almost converging on every single aspect except for one aspect where we are diverging is the in our implementation we are using measurement series instead of measurement itself. So for us, we are not dumping all the information like what Hua has mentioned. Hua's case is more of a iScan, but ours is more of a pass fail. So we don't need to dump all the BER. We don't have to dump all the right, left margin and stuff. So we are using measurement series where the series is just a set of error values, error count, like at what step, at what errors we encountered. So I will upload a JSON file from our side maybe next time we can view the same. I don't have access to this viewer, so I was asking some help from Huad to present our JSON in our next meeting so that we can correlate what is the difference between those two.
Yeah. So there's also a log tag that shows the artifacts according to the sequence number. Yeah, this kind of like the raw JSON artifact. But you can see that yeah, I have these overloaded names and unit and just scramble more information. It's because just have limited, you know, artifact fields to play with. So this is something that it's not standard. And I'd like to hear people's opinion on like how flexible we can have on these things. If it's okay. It's because I remember I asked Adrian once before that what qualifies as the OCP output. Basically, what the answer I get is as long as fits the spec, the JSON output format, it's good. So I'm just being creative here. Yeah.
So I have a question and maybe a comment to your last question here. Firstly, the question you mentioned that you have rescoped your goal in a sense. That when you look at the output of the diag, you now look at it from the viewpoint of a user that would look at maybe this UI and gather signal from this, as opposed to what you're doing before with looking at how you match the outputs that you already have with the spec format, right? So my question is, have you run this output that we're seeing right now on the screen with other people in your space to get some feedback on this, or is this just from your personal viewpoint, what would be useful for a user?
Good question. So I'm aware that even with this output, it's still a bit overwhelming to users who doesn't understand what lane margin test does, right? If you give this output to you know, the data center operator or manufacturing, you know, test engineer, they wouldn't understand like they cannot triage if there's something failed because it's overwhelming. And I already try my best to kind of make it, you know, not overloading them with information and basically okay, I'm the secondary user, and what I want to achieve is that when they see a failure from this output, they can pick out the useful information and send me a bug report, and from there I can already get an idea what the potential failure problem is, the defect, where that may be. And sometimes I don't have to go onto the system to give them, to do more triage in order to give them some instructions.
Right. So you're mentioning triaging, and I don't necessarily think that triaging is supposed to be a function of these measurements and the abundance of data that you're seeing here. I think that triaging should be part of the diagnosis tab in this case, right? If you look at the UI. So the diagnostic output and package should tell you, okay, I failed in this particular way, and you should go to this team or this owner of this space to try to fix it, right?
Yes. Okay. Yeah. Well, I didn't know the whole purpose of diagnosis. What I use it is just end result for this step. Like,
Yeah.
right. Okay. So, and then it, because I don't have all this hardware information here, right? I cannot tell them specifically which piece of hardware to repair to like resealing a plug-in card or something, or like try to.
Okay. All right, so
Right.
so maybe this is actually something that we need to address here, because this is the point of having the diagnosis and the hardware info bit in it, right? You see that the hardware info pointer is on a diagnosis object specifically to say, okay, this passed in your case here, but if it failed because of this hardware piece, or this is what you should be looking at. So when you say triaging, uh, specifically from someone who is not the domain expert in this case, I would say look at the diagnosis and look at any error messages that I haven't seen so far in your presentation. Or maybe there are in the logs section, but error messages would be more precise in saying, okay, in this step, I had this error that I have observed. And then at the end of the step, you have the one uh, diagnosis artifact that it says, okay, out of all of the exercising that I've done in this step, your hardware passed or it failed in this way. Right? Does that make sense?
Yes. Yes. Okay. Yes, but there is something. Okay, it's contradicting. Okay, I don't have one that has the failure. Okay, so this viewer only presents the artifact, the raw output, right? You can see the measurement has a value and the validator, right? So these are all embedded in the artifact. It's up to the receiver, the reviewer, to process if the value is fits in the validator. So there's another component that validates these value and generates these errors and diagnostics. And we do. That's the other agent I was talking about that take these artifacts, and because with all this information here, it can say, oh, this thing error out. If error out is not a valid measurement, it's an error. Okay, the error is in this component. Okay, it will translate what I have here to a hardware information, and then it will generate a more actable diagnosis.
So we can do that as well. Just to clarify, these validators here on the measurements and measurement series are for documentation purposes, right? You can have failures here and still your step to pass. So the fact that you may have a failure in the validation of a specific measurement does not automatically mean that your test step has failed. That is for the diagnostic package to decide whether the step as a whole or the test run as a whole either succeeded or failed. Now, to your last comment with that.
No, not necessarily. It does. The diag itself, the generic diag binary, it does give a diagnosis whether it think pass or fail. Like, for example, here it does generate this. If something it think it fails, it will send this out. Okay, but it doesn't really, since it's only within scope of PCIe, it doesn't know where it failed, what it is. So it relies on downstream interpreter to generate those. Yeah. It can only generate things it knows and fit that information into this format.
Okay. Yeah, I think I get what you're saying. Like the analyzer bit that you're talking about that runs after this has more information than what this diagnostic execution has at the time of the execution, right?
Yes, yes.
Right. So what I'm saying, even from an aggregation viewpoint, the analyzer can take in OCP TV output and then produce a filtered view of the OCP TV output with all of the relevant measurements or hardware info or all of that, and adds new diagnosis from its own analysis, right? Yeah. And it would still produce this kind of output that you can still put in the result viewer and look at it, but from the higher perspective of the analyzer that looked at like more data producing diags, let's say.
Yeah.
All right. I have another question, but Satish has been waiting for a while. So go ahead, Satish.
Yeah. Thanks, Adrian. Ho, I think it's a question for you. So currently, when you're running this LMT tool, are you running it in the iScan mode or in the pass-fail mode, like in your current use case?
Okay, in this particular result is
sorry, not in the particular, like in your actual manufacturing or DC use case. Like, are you running it in the iScan mode and let the result viewer or result parser determine its pass or fail?
Of course, in our production environment, it's pass fail.
It's pass fail. Okay.
Pass fail. It's not in the iScan. Okay. The particular iScan mode is I don't give it where to stop. I don't give it a target offset.
Correct.
And it will just go where the boundary errors out, right? So I don't see. Okay, so there's starting offset and stepping sets. There's no target offset. So that's what I call iScan mode. So it detects the boundary. But in production, I do have a target offset. So it will stop and make sure that whether the target pass or the given these offset passing fail, you have a minimum I size.
Right. So are you planning to do that check, the validation in the LMT tool or in the wrapper which is running the LMT tool?
Both. Same as here. Same as here. Okay. So basically, if I have a target offset, okay.
Yeah.
Or I size specification in the test spec.
Yeah.
The test will generate a diagnosis, like pass or fail when it detects. But at the same time, it will put those criteria threshold in the validator along with the value, right? So that downstream interpreter can use the validator, check the value, and generate its own the diagnosis or error messages, with more hardware specific information.
Sounds good. All right. Yeah, that's what I wanted to know. And the last question is the hardware component info, right? Hardware info in this in the tool, within the LMT tool. So for me, the way I look at it is like we should stick with the PCI spec. According to the PCI spec, what is a hardware component? It's just a BDF and a receiver, right? So I'm assuming we are going to stick with whatever you are having right now as a hardware component, like a BDF and receiver. Like this is like POR. Like this is not the starting point on anything. This tool is going to have a hardware component which is just pointing to a PDF and a receiver ID. Is that right?
Okay. Yes. Yes.
And the wrapper, whoever is running this tool, they will decode this BDF and receiver ID to a real hardware component based on the model what they have been filled.
Yes.
Okay. Thanks. That's fine.
All right, so I'll say one quick thing, and then I have a question before everyone goes because we're almost out of time. About the naming of both the hardware components and the measurements and all of that. In my opinion, this is fine as it is right now. Like if you decide that these names have some sort of encoding in them, in basically saying the test conditions, like you did with the measurement unit, right? I think this is fine as long as this is clearly documented, right? On the other hand, I feel like there is something missing here, and that something is test conditions or fixture, as I was calling it earlier. So maybe we should have a bit of a discussion on GitHub, or maybe in a call to talk about this concept of conditions, because essentially this is what you're encoding in the unit, for example, right now. You say, okay, I shifted the offset by 15% or by whatever number of millivolts. So those are test conditions, right? You are in the condition of having shifted by that amount of millivolts. So those coordinates would likely be better in another object or something in the spec, if it makes sense for other users as well. And I think it generally makes sense for hardware to say, okay, I am testing the hardware, but in this particular condition.
It's, well, the condition, because it's you mean per measurement what condition is, right? You're trying, if you want to add a additional field in the measurement, we have, I was thinking about using the subcomponent location that kind of tell you the condition, like what you call condition, but it's offset, right? But or it's something that you, if it's, what you mean is test specification, it's already in the parameters. The parameter can specify this condition where it goes a for loop, like scan these conditions.
Yeah, but these are like input limits. Like you're saying, sweep my range of offsets from this to this, right? But for the particular measurement, you have a particular set of conditions that you are currently running with for the hardware, right? So that's why I call conditions.
We can use
in any case,
right? We can use some component for that.
Maybe. I don't have an opinion on the actual implementation right now. I'm just trying to propose this idea of test conditions because I don't think it's in the spec, and maybe it's something that we need.
Well, my opinion is that we don't give it. Okay, I think in my case, okay, my experience is that, see here, I cram a lot of information into this unit because the unit doesn't really, well, it's called unit, but there's no specific what it is. We want to have these generic field, like we can call it condition, but people are free, open to put whatever in there.
Yeah. Again, I'm not trying to get into implementation right now.
Yeah.
I'm just talking about the concept of conditions and whether we need that or not. And it looks to me like we need it because you had to say here, step 2 is 005, direction is right.
Yeah.
And that's not really a unit. Direction is right is not a unit, right? Yeah. Okay. We'll continue this next time. My question now is with the people remaining, actually. Are we continuing with this once every 2 week every 2 weeks frequency, or do we have another call next week?
I'm fine
Any
with
opinions?
2 weeks. Every 2 weeks is fine. Me.
Okay, so in that case, I would ask you to like subscribe to the groups.io email, like send an email to the plus subscribe link. It's in the meeting notes. And I'll set up the call there, and you should get like a calendar invite with the meeting and all of that. And I'll set it like every 2 weeks.
Sounds good.
All right, cool. Glad that's resolved. And on that note, thanks everyone for joining today, and we'll see you in 2 weeks.
Thanks.
Yeah. Thanks. Bye.
Thank
Bye.
you.